Hey everybody! In today's video, we're going to talk about relative humidity and dew point temperature. Now, believe it or not, water is in the air surrounding us. So, why isn't it raining all the time? Well, here's why. The air is like a bucket. You can fill a bucket with water, but only so much until the bucket's full. If you try putting more water in after that, well, it's just going to overflow. The air can also hold water, only in this case it's holding it as water vapor, as a gas. It gets there as part of the water cycle through a process called evaporation. Just like a bucket, the air can only hold so much water vapor until it's full. When it is full, we say that it is saturated, and the relative humidity would be 100%. We'll talk about what that means in a few minutes. Under these conditions, the air acts like a bucket that's already full of water. It can't hold any more water vapor, so it starts to dump some back out, and the water vapor turns back into a liquid in a process called condensation, and we get rain. Okay, now I'd like you to open up your note packets to page 11. Write this down. Relative humidity measures how full the air is with water vapor, expressed as a percentage. For example, if we say that the relative humidity is 50%, that tells us the air is half full with water. Now we're going to see there are two ways to change relative humidity. Number one, write this down, is to change the amount of water vapor. And this way is pretty simple. If you look at the diagram in your notes, what we have here are four buckets. The buckets represent the air. Now I want you to notice that the air temperature is 20 degrees Celsius. Now as we're going to see in a minute, the air temperature can also affect the humidity, but in this case the air temperature is staying the same. Notice the first bucket is only about a quarter full of water. Well, if it's a quarter full, we would say the humidity is 25%. Write that down. In the next example, we can see it's about half full with water, so the humidity would be 50%. The next bucket's about 3/4 full, so the humidity would be 75%. And then finally, the last bucket is completely full, so we would say that the humidity is 100%. Okay, the second way to change the humidity is to change the air temperature. Now here's where it gets a little tricky. If you look at the next set of buckets in the next diagram, I want you to notice that the buckets aren't the same size anymore. The air temperature is cooling off as we go from left to right. Cooler air doesn't hold as much water. So as we cool the air, it's like shrinking the buckets. The first bucket, the air temperature is 20 degrees Celsius, which is warm compared to the other buckets. So we have a larger bucket. And you can see the amount of water in that bucket isn't a lot. It's about a quarter full, so we would say the humidity is about 25%. Now I want you to notice from the first to second bucket, the air temperature has cooled off. Also notice that there's the same amount of water in that bucket as in the first one. It's now in a smaller bucket though, which means it's closer to being full. And the diagram's not perfect, but let's say that bucket was about half full. We would say the humidity is about 50%. Now if we keep cooling that air down to the next one, 12.5 degrees, the bucket's even smaller, same amount of water still there, but now the bucket's even closer to being full, so we would say the humidity is 75%. Finally, we cool it all the way down to 10 degrees Celsius. The bucket is now completely full. The humidity is now 100%. Okay, now I'd like you to turn to the next page, and we'll look at dew point temperature. Write this down. Dew point temperature is the temperature of the air when it's saturated, and that means it's full of water vapor. If the air temperature and dew point temperature are the same, the relative humidity is 100% and it rains. So as we're going to see, the dew point temperature depends on the relative humidity. Here we have the same 4 buckets as before, showing us that as the air cools off, it can't hold as much water vapor. We cool the air from 20 degrees Celsius all the way down to 10 degrees Celsius, and that's when it's full. 10 degrees Celsius, therefore, is our dew point temperature. And finally, we're going to see the first set of buckets again. Air temperature is remaining constant, so the bucket stays the same size. But we're adding water vapor, and we're going from 25 to 50 to 75% to finally 100% humidity. The bucket's full. In this case, we have added water to raise the dew point temperature until it's the same temperature as the air. So therefore, our dew point temperature, since the air is saturated, is also 20 degrees Celsius. This is a swing psychrometer. This is the instrument we're going to use to measure relative humidity and dew point temperature. This instrument is essentially just 2 thermometers on a stick, and they spin around. But one of those thermometers has a little piece of cloth on the end of it. What we do is we dip that piece of cloth in some water, and we spin this thing around. As we're spinning it, water evaporates from that cloth. And as you know now, evaporation is a cooling process. So we should see that the temperature on that thermometer goes down a bit. We call that temperature the wet bulb temperature. The other thermometer is dry, so therefore we call it the dry bulb temperature, and that really just measures the air temperature. So let's say you measured a dry bulb temperature of 24 degrees Celsius and a wet bulb temperature of 18 degrees Celsius. Here's how you would find the relative humidity and dew point temperature. On page 12 of your Earth Science reference tables, you'll find 2 charts, one for finding relative humidity and the other for dew point temperature. We'll start with relative humidity first. I want you to notice how the columns are labeled here. On the left-hand side, you will see a column for dry bulb temperatures, and along the top, you will see difference between wet bulb and dry bulb temperatures. So the first thing we do is we subtract the wet bulb from the dry bulb temperature, and we find our difference on the top. Then we match it up with our dry bulb temperature on the side, and we get our answer. So let's do one for practice. Let's say we had a dry bulb temperature of 24 degrees Celsius and a wet bulb temperature of 18 degrees Celsius. First thing we need to do is subtract them. 24 minus 18 will give you 6 degrees Celsius, and that's our difference. So that's what we're going to be looking for on the top of this chart. So to find the relative humidity then, we're going to take our original dry bulb temperature of 24 degrees Celsius, and we're going to find it on the left-hand side of this chart. Then we're going to find our difference of 6 up top, and we will match up those columns. Wherever they meet is our relative humidity. In this case, our relative humidity is 55%. To find the dew point temperature, we use the same numbers, we just plug them into a different chart. This chart can also be found on page 12 of your reference tables.